Today we are going to look into a very critical topic, which is about titanium addition in blast furnaces in order to protect its hearth and extend the service life of blast furnace. Now, just before going in more detail, let us try to see that how it work, how titanium addition in blast furnace work. As you must be knowing, the titanium addition being done by TiO2 bearing material, and this material forms a protective titanium carbide and titanium nitride in the salamanders, the wear tear areas of the hearth. The only thing which I want to stress upon is that only the titanium which is present in hot metal is going to fulfill our objective of this campaign life extension or protection of wear and tear. The question rises that what affect titanium transfer to metal? So here primarily there are three reasons, there are three parameters are there which decide that how titanium in hot metal can increase. One is the hot metal temperature. So as temperature goes higher, presence of titanium in hot metal increases. So hot metal temperature is one of the most controlling parameter. Second is the presence of TiO2 in slag. So if higher TiO2 in slag will be there will be more titanium in metal. So we must have to aim a certain percentage of TiO2 in blast furnace slag. So higher the slag, higher the TiO2 in slag, higher the titanium in hot metal. The third and important is about the basicity. So as basicity increases, titanium transfer suppressed. So we need to optimize basicity while obtaining a maximum benefit of titanium in metal and subsequently titanium carbide and titanium nitride formation in the salamander spots of the blast furnace earth. MgO has a minor impact. Now, industry data also confirm these trends that when TiO2 addition is done in a blast furnace, there is a drop in thermocouple temperature, which were before application of titanium remains high, and only 13% of titanium goes into hot metal. So this is a very sensitive data where whatever TiO2 we are using, only 13% of titanium goes into hot metal, which solves our targeted objective of taking care of hearth. So finally, this is very important to establish that how the use of titanium will be optimized. So target slag of titania should be more than 2% for better transfer. So this is one of the most important aspect that is to be fulfilled. Second part, as we discussed, that higher basicity hinder the transfer of titanium, and hence we need to have a moderate basicity. Around 1.1 is good enough to take care of. And third thing is the extension of residence time. So within this time, things can be better balance and retention of titania increase in hearth. And hence, based on those discussion, we end up with a conclusions. which shows that it is about optimization, it is about smart uses of TiO2, because it is a very costly material, and without optimization, without a smartly use, we are not going to save. And we need to monitor the slag chemistry, the metal temperature in a very strict fashion. Otherwise, as we already discussed, any spike in the basicity hinder the solubility in the transfer, and our TiO2 unnecessary will goes in vain. So this is all about a smart uses of TiO2 in blast furnace and driving our objective of campaign extension. Thank you.